Hello, I'm Rebecca the Maths Lady, and this video is all about finding fractions of amounts. In this video, I'm going to explain how we teach this topic using block methods and the proportion bar, how these visual methods link to the standard abstract method, and also how the proportion bar links this to other mathematical topics and connects children's understanding of maths. So if you don't need this video, here's your quick skip link to the next video, which is all about dividing fractions by whole numbers. Now, finding fractions of amounts is a topic that I've looked at before in a video for teachers of children aged 7 to 9. You don't need to have seen that video to understand this one. I am going to start this topic from scratch, but if you find this video goes a little fast and maybe you're working with 9-year-olds who are just encountering this topic, then that other video might be a better one for you. So here's a link to it now. Right, let's get started with a very simple question to focus on first. Find 3/4 of 40. How did you do that? Well, you might just have divided 40 by 4, which is 10, and then multiplied by 3. It may be that you were taught that method and you just use it without thinking. That's not good enough for teachers. Teachers can't just rely on recipes and spells because children will ask why. So we need to give them a picture. You could give them a circular picture where they split the 40 into 4 equal parts, 10 in each quarter, and then take 3 of them to show 3/4, so that's 30. It's the same as what you've just done, but it has understanding, coherence, and it makes sense. But in today's video, at ages 9 to 11, I'm going to ask you to focus on linear methods for drawing your fractions. Now, the easiest way to do that, to show 3/4, is just to draw 4 blocks. And for any fraction, you can just draw the number of blocks in the denominator. Then we share out our 40. Hopefully everyone can clearly see that's 10, 10, 10, 10. And you take 3 of those quarters. So your answer is 30. Now, if you have children reliably drawing block models for finding fractions, you're doing pretty well because those children have a structure, they have a deep understanding, a visual understanding of what they do, so they're likely to remember it. But what I'm going to suggest at the very best level of teaching is that you start to move on to using a proportion bar. Problem with the block method is that the length of one bar tends to increase as the denominator of the fraction increases. So the size of one whole is not consistent. And the proportion bar, which I introduced in the video on equivalent fractions, here's a link to that one now. If you've never seen the proportion bar, it's worth having a good look at it before we start on this video. The proportion bar controls the size of 1, and that's going to help children to make lots of links between different areas of their maths and to more deeply understand what's going on with fractions of amounts. So if you had a question like find 3/5 of 65, you could draw 5 blocks, share that into 5 blocks and take 3 of them. It's really not much different from using the proportion bar when you're just working on one question. With the proportion bar, the free one is at mathsbot.com. You click on manipulatives and then on bar modelling. Then you quickly set up a proportion bar for 3/5. And then children could put 10 in each fifth, just as they would with the blocks, and that leaves them 15 to share out. And if they can't see that that splits into 3s, they can mark one at a time. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And then they'll see that there are 13 in each section. So in 3/5, there's 3 lots of 13, which is 39. And if you'd used the abstract method of dividing 65 by 5, you'd have got 13, and then multiplying by 3 would have got you your 39. So the abstract method and the visual method connect together. And that's the absolutely crucial thing that we want children to understand when we're teaching this topic. So in the early days of working on this topic, it's really important to keep the numbers small and simple to work with so that children don't have to worry about working with the numbers too much, so they can focus on the visual structure of what they're doing. So if you looked at a question, find 6/7 of a number, I would probably make that number something like 70. So it's really easy. So when you draw your proportion bar for 6/7 and you're sharing the 70, everyone can see it's going to be 10, 10, 10, 10, 10, 10, 10 to share it fairly between the 7 parts, and 6/7 is going to be 60. And you can do really hard fractions with simple numbers. If you had a fraction like 4/13, they can cope with that, 4/13 of a number, if you make the number something like 26 and let them puzzle, and they're going to see that it's 2 in each block. It's a really nice level of challenge as children are developing this understanding that they have to split the total amount into the number of parts in the denominator of the fraction. In this case, it's 13. And then take the number of sections in the numerator of the fraction, which in this case is 4, and you have your answer. And you want to do lots of those until children are totally secure with what they're doing by working with easy numbers. And then you can move on to some tricky numbers just to see if they can still do it, and to practice working with tricky multiplications and division. But if they can't do the easy ones, then don't move on. They're not ready for this, and they'll start working without understanding. So if we go back to this fraction 3/5, we could try the question, find 3/5 of 27,008.2. And if I set a question like that, I would let children discuss it, puzzle with it, try and work on it. And they are going to have to try and divide that big number, 27,008.2 by 5. You can't split your two 20,000s, so we carry them and they become thousands. We've got 27,000s. If we split those into your 5 sections, we can put 5,000 in each section. You could do this with place value counters, exchanging them where necessary. So 5,000s, 2 of your thousands are left over. We're going to have to exchange them into hundreds. So we've got 20 100s. 20 split into 5 equal parts, that's 4. So there's 4 100s going into each part. Again, you could do it with your place value counters. If you don't have place value counters with large enough values, you can make some with paper. Just make them square really quickly. Okay, carrying on. We've got no 10s, so that's going to be nothing to put in each section. We've got 8 1s, so we can put 1 in each section, and we have 3 left. So we have to change them into tenths. We've got 32 tenths, so we can put 6 in each section. We're going to have to extend this because we haven't used them all, because 6 5s are 30, so that leaves us 2 tenths to change into 100ths. So we've got 20 100ths, they'll share. We've got 4 100ths in each section. So 5,401.64 in each section. You can write that 5 times into those sections. Beauty of doing it with place value counters is that you can see that that whole number has split into 5 of that number. And of course you can check it by adding them back together and checking that you get your original number. And then you can either add them up, add 3 of that number together, or you can multiply by 3. So there's loads of your primary maths going on in there. We've done decimals, we've done dealing with decimals in division, we've done short division, we've done multiplication, we've done fractions of amounts. It's all got to be coming together at this stage. I would just set children a couple of questions like this, one for them to really puzzle with, and hopefully one for them to become fluent with. And if they can't do it, you want to dig into exactly what it is they're stuck with and make sure you fix that particular point in their understanding. There are previous videos on all these ideas. If If you were struggling with the decimals in the division, there's a video on 6 ways of dealing with divisions which don't give whole number answers, and that video, here's a link to it now. Let's look at another tricky question. Find 6/7 of 85, and here's your proportion bar picture. Find 6/7 of 85. Now if you got your place value counters out, you'd have 8 tens, so we could put one of them in each section. That leaves us with 15. We could put 2 in each section, but we've got 1 left over, and it doesn't work nicely as a decimal. Let's just do that quickly as a short division. I'm trying to do 85 divided by 7. We could give everybody 1 10. We had 1 left over, which we've turned into ones. So we've got 15 ones, and each person gets 2. And we could put remainder 1. But if you watch my video on dealing with fractions that don't give whole number answers, the best thing to do in this case is to write it as 1/7. 12 and 1/7. And how to do that is explained in that video. So then we need 6 lots of 12 and 1/7. That's a question that children should be able to puzzle with at this level, and if they can't, then you need to dig into why, and you need to fix whatever problem it is that they're stuck with. And of course, if you've done long division with your children, you can deal with fractions where there are more than 12 parts. Here you'd have to find a number that divides by 13. I probably wouldn't do the bit where you don't get a whole number answer at the same time as doing long division, but you could if you wanted to. But if you start with a number that will divide by 13 and try to find 4/13 of it, then children will be pushed to use their long division in this context, which is a powerful challenge for them. And if you had a fraction like 13/18 of an amount, they'd also have long multiplication in there. Once they've divided by 18, they'd need to multiply by 13. Now I need to talk briefly about why it's best practice to move to the proportion bar rather than just using a block method. And the key reason is that it just lays fabulous foundations for all of children's understanding of proportion, which can be fractions of amounts, percentages of amounts, or ratio. So if we look again at the bar model for finding 3/5 of an amount, then this is also the bar model for sharing an amount in the ratio 3:2. You're finding 3/5 of the amount and 2/5 of the amount in the other share. Now we're not doing ratio today, but hopefully you can now see how if we work with the proportion bar now, when we move on to ratio, ratio is going to drop into place as a topic for children. And similarly, when you're working with percentages, you can have a proportion bar in 100 parts. And the more that children have seen fractions in proportion bars, the more easily they're going to understand those percentage bars because they're the same thing. The other part of this that connects together is that if you're working with a proportion bar like this, which we used for comparing fractions, you can now really clearly see that 2/3 of an amount is going to be bigger than 4/7 of an amount. So the two topics of finding fractions of amounts and comparing fractions fit together very easily with this structure if you are having to compare fractions of amounts. All of math starts to fit together when you have the right structures in your imagination and you're taught to use them wisely. And of course there's loads of work from age 11 up that fits beautifully onto the proportion bar too. So please make the proportion bar your friend, whether you're tutoring and using it on a laptop or whether you're teaching from the front of the class and you've got one on an interactive whiteboard. You need a proportion bar. You need a proportion bar, you need to be fluent with it, and you need to use it on a regular basis so that children are always imagining it. Your extension work, well, there was lots built into this teaching strategy, and here we hit a standard extension work strategy. First of all, we had lots of extension work within the teaching. Secondly, let's do some reification. Let's write a finding fractions of amounts problem and ask children to invent a story that problem could be about. And then finally, you want cross-curricular problem solving. where children don't know which maths topic is required to solve the problem that they're given. And even better, if you can put in some mathematical games, sometimes that children really enjoy and are just desperate to get to, then that's such an incentive for them to concentrate on the maths in the lesson and get it done, because it's a reward. So your takeaways from this video: to find a fraction of an amount, you need to draw a block bar or use a proportion bar so children see why they are dividing the amount by the numerator of the fraction, because they're splitting the whole amount into that many parts. And then they're multiplying the size of one part by the numerator of the fraction, because they are taking that many parts. You want to start by working with numbers children can work with really easily, so they get a deep understanding of this topic. Then you want to challenge them to see if they can use the trickiest aspects of division that they've done and still cope. It's great to use the proportion bar if you can, because it links together so many different mathematical topics, and the more they use it, the more secure foundations they have for their future mathematical understanding. And your extension work, a lot of it's built into the teaching. Use reification and do some cross-curricular problem solving and games. If you haven't subscribed to the channel yet, please subscribe so you can find it again. If you've time to give us a like, that's fabulous. If you can comment, I'd love your questions. Criticism is really welcome, because that's how I learn. And if you think you know people who might like these videos, please let them know about them. Thank you for taking the journey to becoming a fantastic maths teacher. Bye for now.